In this lesson, you will learn and apply the basic laws of logarithms. And there are three laws that we are going to discuss. And here are the three laws. This looks pretty intimidating, right? Because there's no numbers anymore, it's just all letters. But we're going to explain how this works step by step. So the first law we'll take a look at says that log base b of m times n equals log base b of m plus log base b of n. So the b, m, and n are just any sort of number. And what we're saying here is that if you have a logarithm of two numbers being multiplied together, so m times n, what I can do is I can break apart the logarithm as an addition problem. So what I'm going to do is informally prove to you that this is true. So here, for example, we have log base 10 of 10 times 100. Now we know 10 times 100 is 1,000. And the question is, what is this equal to? Well, it's equal to some number, so we'll call that x. And to convert from this into exponential form, we would say that 10 to the x power equals 1,000. So the question is, what is x? Well, 10 to what power gives me 1,000? That's going to be 3, because 10 to the third power would give you 1,000. Now the other way, according to this first law, it says that I can break apart this initial problem so that I have log base 10 of 10 plus log base 10 of this 100. We're going to show to you that we're going to get the same solution that we got the other way. Log base 10 of 10, you can think of that as equal to some number. So 10 to the x power equals 10. Well, 10 to what power gives me 10? That's going to be 1. 10 to the first power gives me 10. Same thing over here. 10 to some power gives me 100. Well, 10 to the second power gives me 100. So this would be the same thing as 1 plus 2, which would be 3. Now notice in both cases, we get the same solution. Over here is 3, and over here it is also 3. So we just showed you that this first law is indeed true. Now I'm going to show you two examples where we use this first law. Example 1, we have log base a of 3 plus log base a of 4. And you're told to write this as a single logarithm. So here, we said that if we have the same base, which is the case right here, we have base a and a, then what I can do is I can combine or separate the logarithm. Where if you see the addition sign, I can combine into one logarithm by multiplying the 3 times the 4 to give me 12. So my solution here would be log base a of 12. And I can do that once again because the base is the same and I'm adding these two logarithms together. So the law says that I can break it apart or I can bring it back together. Here's another example. You have now 3 logarithms put together where all the bases are the same. Every base is b and every logarithm is being added together. So because the base is the same and you're adding together, I can then multiply the 3 times the 4 times the 2 to get 24. So my solution would be log base b of 24. So now we're going to look at the second law. Second law says that if you have a logarithm where you're dividing two numbers, so m divided by n, what I can do is I can separate it into two logarithms where I have log base b of m minus log base b of n. So it's really just like the first law, where the first law said if you multiply, you can add the logarithms together. And the second law says if you're dividing, you can subtract the two different logarithms. So very similar to the first law. So an informal proof that this is true, we have log base 10 of 1,000 over 10. Well, 1,000 over 10 is 100. And what is this equal to? Well, it's equal to some unknown number. So we have 10 to this number, some value, equals 100. So 10 to the x power equals 100. So what is x going to be? We have 10 to the second power gives me 100. So x would have to be 2. Now the second law says I can also separate it, where I have log base 10 of the top number, so of 1000, minus log base 10 of the bottom number, so of 10. And here, if we take log base 10 of 1000, that is equal to something. So 10 to some power gives me 1000. Well, that's going to be 3. 10 to the third power gives me 1000. And then log base 10 of 10, these two numbers are the same, and that's always going to equal 1. If you don't know that, you can set that equal to x, and we have 10 to the x power equals 10. So 10 to what power gives me 10? That's going to be the first power. So what I have is 3 minus 1, which is going to be 2. Notice we get the same solution either way. So therefore, we have just shown to you that this second law is going to be true. And the second law says I can either break it apart into 2 logarithms, or I can put it back together into 1 logarithm. So here we see log base 3 of 30 minus log base 3 of 6. And you're told to write this as a single logarithm. So to do that, I need to combine back into 1 logarithm. And we see here we have the same base of 3. We're subtracting. So what I can do is combine them by dividing the 30 and the 6, which is going to give me log base 3 of 5. Here's another example where now we have 3 logarithms being subtracted. What I can do is I can look at the first 2 first, and then do the third one after. Because we have the same base x and base x, and I'm subtracting, I can divide the 45 by the 5 to give me a 9. So now I have log base x of 9 minus log base x of 3. And then one more time, do the same thing. Base is x, and we're subtracting, so I can divide the 9 and the 3 to get 3. So my solution is going to be log base x of 3. By the way, notice for these first 2 laws, it's basically just pattern recognition. We're learning the patterns on how to combine the logarithms. And this third law we're going to look at says that if we have an exponent, so for here we have a k, what I can do is I can bring that out in the front of the logarithm. So we'd have k times the log base b of m. So to show to you if this is true, we're going to look at log base 10 of 10 squared. Okay, well 10 squared is 100. So log base 10 of 100 equals something. Well, that's going to be 10 to the x power equals 100. So x would have to be 2, because 10 squared would give you 100. So then, looking at the other way, if we were to bring the 2 in the front, so now we have 2 times log base 10 of 10. Well, log base 10 of 10 is going to equal 1, right? These two are the same numbers. That's going to equal 1. So I have 2 times 1, which is equal to 2. Notice we have the same solution either way we look at it. So this third law would be true. Now, using that third law, what I can do, if there is a 3 in the front, I can bring it up as the exponent, and vice versa. If you have the exponent, you can bring it out in the front. But typically we're going to go this way, where we want to bring this number in the front up as your exponent. So what we have is log base 5 of x to the third power. Here the 4 is in the front, it's being multiplied. I can bring that up as your exponent. So I have log base x of 5 to the 4th power. So now we learned all 3 of the laws. And in this next example, we're going to put everything together and express this as a single logarithm. Now, when you have to use all 3 of the different laws to combine into 1 logarithm, you always want to begin with that third law, where if there's a number in the front, such as the 4 and the 2, I need to bring this up as the exponent. So now what I have is going to be log base 10 of x to the 4th power minus log base 10 of y to the 2nd power. And then I can combine by looking at the subtraction sign. And the base is the same, base 10 and base 10, So I can combine, and the subtraction sign means that I'm going to divide in order to combine. So I take the log base 10 of x to the 4th power, and then divide that by this y squared. And this would be my solution. I have combined into one logarithm. The last thing we need to know how to do is to solve a logarithmic equation. So for example, here we have log base 3 of x plus log base 3 of x minus 6 equals 3. And what I want to do is on this left side, I need to combine into one logarithm, because from there I can then convert out of logarithmic form into exponential form in order to solve. So here to combine, we see the base is the same, both a base of 3, and you have those two logarithms being added together. So because they're being added together, what I can do is I can multiply the x and the x minus 6. So what I have is going to be log base 3 of x times x minus 6. Well, x times x minus 6 I can distribute, so x times x would give me x squared, x times negative 6 would give me a negative 6x. So now we have one logarithm equal to a number over here. And what I can do now is convert out of logarithmic form in order to solve for x. So here the base is 3, so the base in exponential form would also be a 3. A log is an exponent, so the 3 over here is your exponent. So what I have is 3 to the 3rd power equals the x squared minus 6x. And 3 squared, or 3 cubed, sorry, is going to be 27. And I want to get this quadratic equation equal to 0. So I want to subtract 27 from both sides to get this to cancel. So when I do that, I now have x squared minus 6x minus 27 equals 0. And then from here I can solve this, and the easiest way is to factor, where I have in parentheses two things, and to get x squared, I have x times an x. To get negative 27, if I take a 9 and a 3, then when I multiply I get 27, but I need a negative 27. So if I make the 9 negative, the 3 positive, that would give me negative 27, and when I add them together, negative 9 plus 3, I'd get the middle term of negative 6. So I can factor this to get x minus 9 times x plus 3. I can then set each part equal to 0, where x minus 9 equals 0, or x plus 3 equals 0. So x would equal 9, or x would equal negative 3. So we have solved for x. Now just be careful that you check your answers when you are finished, because the 9 would work, but the negative 3 would not. If we plug the negative 3 in for x, we'd have negative 3 here, negative 3 here. So we'd have log base 3 of a negative 3. And that's equal to something. Well, what is that equal to? So 3 to the x power equals negative 3. Well, we have a positive number for your base. It does not matter what I raise this positive number to, I will never get back out a negative solution. So this negative answer does not work, because I cannot have an exponent that would give me a negative number back out if we started with a positive base. And that concludes our lesson for today. We will see you next time.